Identify the type of alloy described. Steel is an interstitial alloy formed when smaller carbon atoms fit into the interstitial spaces, the gaps, between the larger iron atoms in the metallic crystal lattice. Understand the structure of pure metals. In a pure metal, or an alloy with very low carbon content, the metal atoms are organized in highly regular, uniform layers. Because the atoms are all the same size, these layers can easily slide past one another when a force is applied. This sliding mechanism is what makes metals malleable, capable of being hammered into sheets, and ductile, capable of being drawn into wires. Analyze the role of carbon in the iron lattice. Carbon atoms have a much smaller atomic radius than iron atoms. When carbon is introduced into the iron matrix, these smaller atoms sit in the spaces between the larger iron atoms. Evaluate how carbon affects rigidity. The presence of these differently sized carbon atoms distorts the regular crystalline lattice of the iron. This distortion introduces friction and creates lock points that disrupt the neat, sliding planes of the iron atoms. Relate carbon concentration to the properties shown in the table. Low carbon steel, less than 0.2% carbon, contains very few carbon atoms, leaving the iron layers relatively free to slide. This is why the table describes it as malleable and ductile. High carbon steel, 0.6 to 1.5% carbon, contains a significantly higher density of carbon atoms, leading to widespread lattice distortion. This makes it extremely difficult for the iron layers to slide past one another, making the alloy hard, brittle, and highly rigid. Select the matching option. This structural explanation corresponds perfectly to option D. The correct answer is option D. The additional carbon atoms within the alloy make it more difficult for the iron atoms to slide past one another.